It's just she's like soft. It's not really.
Oh, in the presentation. Oh, I thought it was like something associated. Wait, oh yeah, Chinese. Wait,
All right, everyone. Can everyone quiet down, please? All right, thank you. We're going to start with demo number 5 now soon. I think there was a lot of confusion about the slip days. Those should be fully updated now. So if you still have any questions, just put it on the ad or email us. And then the last thing is the hack challenge is finally up and we're starting it. I put the link in the ed discussion form. So go to the ed and make sure you sign up with the group. Make sure you sign up for the hack challenge. If you're not signed up by this Friday, you will not be in the hack challenge. I want to stress that. It is not done by just me. It's done by all the other courses together. And on Friday, they all go together, they look at the spreadsheet and they make the teams. So if you are not in the hack challenge by Friday, you will, like if you haven't signed up, you're not going to be in it at all. So make sure you do that. You know, if you have friends who aren't here today, make sure you tell them too. I'll send a follow-up announcement Thursday reminding everyone, but you know, please don't forget. And unfortunately, that's something that we can't extend, not like the homeworks. So make sure that you actually do sign up by Friday.
Okay, hi everyone.
Yeah, sorry.
Is signing up just joining the ed thing, or is it more than that?
Joining the ed, and then on the ed, when you join it, you should see that there is like a sign up form in that ed discussion.
Thank you.
Yeah. Yeah.
if you have like 2 other people, but like you're missing a 4th, and then like can you still request to be in a group?
Yeah, and we can like find a 4th or not. Sometimes it'll be just like Google 3. But yeah. Okay, any more questions about the hack challenge or signing up or getting on the ed? No. Okay, perfect. And let's start with the demo.
Welcome to demo 5. Today's demo is on containerization. So as a reminder, containerization is the way that we package our applications and their dependencies together, which makes them portable and easy to run on different environments. So to handle containerization, we use Docker. On Monday, we covered the basics of Docker and how to build Docker images. Today, we're going to continue working with Docker and build on what we learned from Monday. So today, we're going to introduce Docker Compose. So far, we've been running our applications using Docker run, where we need to specify parameters like port number, repository name, and different flags. But typing these out each time we want to build our image can be repetitive. So Docker Compose allows us to define these configurations in a Docker Compose file. And then once we have this file, instead of typing a long Docker run command, we can just call Docker Compose up. And this command's going to read that file and run our application with the configurations we specified, which will save us time and reduce the chance of errors. So Docker Compose is also really helpful when we have applications that run multiple containers. In industry, we have complex applications, and those often have different services that we run in multiple different containers. So for example, in an app like Google Maps, we might have a service to calculate like travel times between locations. We might have a service to display the map view, and another service may be responsible for like gathering public transit information. So each of these services will typically run in their own container. And with a Docker Compose file, we can manage these services in a single configuration and run them all at once. For the scope of this course, we'll keep things simple and we'll only use one image, but it's still good to know. So to get started using Docker Compose, we'll make a new file called docker-compose.yml. In the first line, we need to specify the version of Docker Compose we're using. So we'll use version 3. The next thing we want to specify is which Docker images we want to run and any configuration settings we want to give them. So we do this with something called a service. And to set up a service, we start by using the services command. And then underneath, we're going to give our service a name. So I'll call our service for today demo. And now we need to tell Docker Compose which image to use for our service. So we do this by typing image and then the name of the image we want to run. Since we're working, yeah, okay. And then the next thing we want to do is define the port we want to run our image on. So we want to map our port 8000 on the Docker image to port 8000 on our actual computer. And the way we do that is by writing ports and then the port mapping. So that would be 8000 to 8000.
What is it?
Wait, why do we need two numbers there?
So we're basically saying that we want to map like 8000 on the Docker image to 8000 on our actual computer.
Okay.
So now I'm gonna build an image. And now we can just start our Docker container with the command docker compose up. So now our Docker container is running, and you can see that every time we run our Docker container, our terminal gets clogged with like a lot of stuff. And if we want to run our container without clogging up the terminal, we can add the -d at the end of our command. The D stands for detached, which means our container is running in the background instead of occupying the terminal.
Could you show us the source code didn't have the Docker file in it? Can you show what it has?
Oh, there. Yeah, this should have been
Yeah,
covered.
yeah, it was the same one that I went over yesterday in lecture.
Oh, okay.
It's,
I re-downloaded the source from like the to-dos and it didn't have it.
Oh, okay, yeah, it's right there in case you need it.
For the other file, how do we know the name of our image?
The name of the image should have been the one that you built yesterday. But if you weren't here, you can just use the command docker build and then -t, and then you can specify the name of your image afterwards, and then just put the dot for like all files.
And is the slash, is that like indicating a different with like directory, or is that like just a way of naming?
Yeah, so I think you covered on Monday, pushing through.
Yeah, so image, are you talking about the after her name, like right before demo?
Yeah, yeah.
Yeah, so her name there is like her Docker username.
You should have done
And
it.
so under all of our Docker like usernames, username, et cetera, you're gonna have different containers or images that you can have. So this is specifying under whose Docker username it is. And then the slash means, okay, in that person's Docker, then put this name, so demo 4. So after the slash is like the little name, you can put like whatever name you'd like. But then before that, it has to be specifically your Docker username.
Yeah, so just to reiterate, if you don't have your Docker Hub username behind your Docker image, the image will work on your local computer, but you won't be able to upload it correctly to Docker Hub. So make sure you prepend your Docker Hub username with a slash before your image name. Okay, so now that we have our terminal free, we can run commands to check the status of our Docker images. So I can run Docker PS. And this command is going to provide us a list of active containers and some useful details like their container ID, status, ports, and other stuff. And then if we want to stop running our container, we can write Docker compose down, and that will stop our container. Does anyone have any questions about Docker compose?
So even if you closed your laptop, the website would still be accessible.
Yeah, but it's only running on like your local laptop, so you'd have to like open it back up again.
Oh, I see.
Let's move on to talking about environment variables. So to recap, environment variables are variables you set within your computer's working environment outside of your application code. So you can think of it as a private area where you can define and store values that your application can access without hard coding sensitive information directly into your application. And environment variables are useful for keeping sensitive information safe. So imagine we need to log into a service using a username and password. We don't want to put our username and password directly in our code because then if we push that code to GitHub or we package it in a Docker container, other people could potentially find those credentials. So the workaround for this is to create an environment variable file where you define variable names and the values associated with them, and then you let your computer read the variables from there. So let's create an environment variable file. These are traditionally named .env. And in our env file, we can define variables and their values as a key value pair. So I'll create an environment variable name, and I'll set that value equal to my name. And then I'll create another one, net ID, and I'll put my net ID. And following the traditional standard, we capitalize our variable names. So next, to tell our Docker Compose file which environment variable file to use, we'll add a line in our Docker Compose file, env.env. So now let's show how these environment variables are used. So let's create an endpoint in app.py that returns hello, and then the value stored in my name environment variable. First, we have to import OS at the top of our file, which is our operating system. And then under the home route, I'll write a new function called greet user. And this function will just return hello. And then we'll write os.environ and pass in the environment variable name. Now we have to rebuild our image since our current container doesn't take into account the information in the .env file. Okay, let's modify our Docker Compose file with the new image name, and then we'll be able to hit our endpoints. Okay, so now if I navigate to our endpoint, I see I get hello, Sophie. The reason there's no space there is I forgot to add like an empty space before I concatenated our variable with the string. Yeah, so that is working now. Does anyone have any questions about environment variables? Yeah.
How did you retake the image for it's with the Docker?
What?
Like you said, you recaptured the image after you made the change to the Docker file.
Oh, yeah, then it was just the same command as you building the image,
Oh,
but in the version, we changed it, so it was instead of 1.00, it was 1.01. Or like 02 or 03.
okay.
So you just have to make sure you update the version. So it's an indicator that you have a new image, but it's just like the same command, you just run it again.
You just changed the version.
Yeah.
What happens to the old images? Like the 01, 02?
Oh, they still exist unless you like actually go in and specifically delete them. They just get you can kind of think of it as like overwritten, or like the newer images get put on top, so that's what you'd use when you build it. But they still exist, they don't get deleted.
Okay, so let's say that one of our Docker containers goes down and we want to analyze exactly what's in this Docker container. The way we can do that is with the command docker exec. So if I stop running this and then run it again in the background, I can write docker exec -it, which stands for interactable, and then pass in the container ID, which I'll just get using docker ps really quick. And then the keyword bash just represents our return type. So now we're inside of this user app directory that we defined in our Docker file as our working directory. If we do ls, we see that all of our files have been copied over successfully. But if there were any errors, you'd be able to see terminal output that details them now. And the way that you exit this is just by typing exit. Okay. So let's go ahead and push this demo 5 Docker image. So the first thing we want to do is type Docker login. And as long as you have Docker running and you're logged in there, it shouldn't ask for your credentials. And then if we type Docker push and then our image name, should be able to see that we've pushed our image to Docker Hub. And we see that we have the image that we just made pushed to Docker Hub. And then next, if we want to pull from Docker Hub, it's pretty much exactly the same. So let's pull a different image from Docker Hub. We'll pull docker/hello world. So I just write docker pull and then the image name. That image might not be working right now. But yeah, the way we pull from Docker is just Docker pull and then put the image name in. And then to run that image, we would just write Docker run and then specify the image name. That's all we have for demo today. Now we're going to move into a quick Kahoot.